Number 15, use the dot grid to draw one rectangle that is similar to the one below, and one rectangle that is not similar to the one below. Label the rectangles you drew similar and dissimilar. So first let's get the dimensions of this rectangle. We see that if we start at this vertex, there it passes through 1, 2, 3 dots. So that's 3 units for the height of that rectangle. So sometimes students will say 4, and I know how that happens. If you start at this vertex and you count 1, 2, 3, 4 dots, but the dots don't really represent the units. For example, if these were centimeters, you wouldn't start counting 1 right here because you haven't moved yet. It's 1 when you move 1. 1 centimeter, 2 centimeters, 3 centimeters. And similarly, if you do the base of this rectangle, 1, 2, 3, 4, 5 units or centimeters or whatever it is. So we've got a 3 by 5 rectangle. I could easily draw a similar rectangle by just using a scale factor of 2. So just trying to get a straight line here. Scale factor of 2, so 1, 2, 3, 4, 5, 6. And then the base will be 5 times 2 or 10. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. And just as long as you put your units here, your dimensions, then even if you miscounted or something, I would know that you meant to scale it up by a factor of 2, and that would still count as correct. This is similar. For dissimilar, there's lots of things we could do. We just need different scale factors. Like, for example, if the scale factor for the height is 1, if I don't change the height at all, but I change the base by something other than 1, like, let's just scale it down. Let's just make a 3 by 3 square. It's still a rectangle, right? But it's definitely not similar. The height has been scaled by 1, not changed, but the base has been scaled down by 3/5 to give you a base of 3. So this is dissimilar. It might be best shown just by comparing corresponding sides. So 3 over 3 is not equal to 5 over 3. This is 1, and this is 1 2/3. Something greater than 1, because it's improper fraction. Okay, last problem, problem 16. A 24,000 gallon pool is being filled at a rate of 40 gallons per minute. At this rate, how many minutes will it take to fill the pool 3/4 full? So we want to know how many minutes, we want to know how many minutes to get the pool 3/4 full. So we're comparing minutes to gallons. We just need to figure out how many gallons is that. 3/4 of 2,000. 3/4 of 2,000 gallons. This is 4 divided by 4 is 1. 2,000 divided by 4 is 500. So that's not 2,000 gallons. I just made that up. 3/4 of 24,000 gallons. We still have a common factor of 4 here, which is nice. 4 divided by 4 is 1. 24,000 divided by 4 is 6,000. So that's going to be 18,000 gallons. Our ratio table can look like this: gallons and minutes. We know from the unit rate here, we can fill 40 gallons per minute, so per 1 minute. We want to know how long it will take to fill 18,000 gallons. So, I don't know. Oh wait, there's a scale factor going this way. You know what, let's just do a proportion. 40 over 18,000 equals 1 over x. My cross products will be 40x equals 18,000 multiplied by 1, which is just 18,000. and we divide both sides of the equation by 40, we'll find x. I'm going to factor out 10/10, crossing off a 0 in the numerator and denominator, and my division is 1800 divided by 4. There are 4 4s in 18, 4 4s are 16. Subtract to get a difference of 2, bring down the 0, there are 5 4s in 20. And we need a number in this ones place, which is a 0. 0 4 is a 0. So 450 minutes. Let's see what the question is asking. At this rate, how many minutes will it take to fill the pool 3/4 full? So 450 minutes. There might be an inclination to turn that into hours. Since it asks for minutes, we'll just leave it that way. And hours, that would be 7 60s is 420, so 7 hours and 30 minutes, or 7.5 hours to fill the pool. Okay, that completes the review. Thanks for studying hard for your test. I know you're going to do well, and I'll see you tomorrow.